Today we will be talking about rational numbers. Okay, rational numbers are numbers that can be written as a fraction. And as we know, fractions can also be written as decimals and percents. So what we're going to take a look at today is turning these fractions into decimals and then determining whether my decimal is a terminating decimal, which means it stops. Okay, so that would be a number like 3.8. Okay, 3 and 8 tenths. Technically, there's a zero that continues forever and ever, but because it's a zero, it doesn't change the value. So we drop that off, and that shows 3.8 or 3 and 8 tenths as a terminating decimal. A repeating decimal would be something like 1/3, would be 0.33333, where that 3 repeats forever and ever and ever and always. Okay, that is a repeating decimal. Okay, so a terminating decimal stops, a repeating decimal continues on forever. Okay, and we often represent that with a line over top of the number that shows that that repeats. So if we had 56 hundredths repeating, okay, so 0.56 repeating, that would be 565656, okay, forever and ever. That would be a repeating decimal, okay? So fractions will either be one or the other. They will be terminating or they will be repeating. And that means they are rational numbers because they can be written as a fraction. Okay, so 7/8, if we are writing that as a decimal, we are going to divide. Remember, our fraction bar also means division. So we would be doing 7 divided by 8. 8 goes into 7 0 times. 8 goes into 70 8 times, and that would be 64. I would do some subtraction here. I get a 6, bring down a 0. 68 goes into 67 times. That would be 56. Subtract, and I get 4. Bring down a 0. 8 goes into 40 5 times. Okay, I make sure that that decimal does get brought up. So my decimal is 0.875, which would be 875 thousandths, which is a terminating decimal because, again, this stops 8 times 5 is 40. We subtract, we get our 0. This means it is a terminating decimal. Okay, 2/5, I would do the same thing. I'm just dividing here. Okay, 2 divided by 5. 5 goes into 2 0 times. Bring up my decimal. 5 goes into 20 4 times. 4 times 5 is 20. Subtract, I get my 0. We have another terminating decimal. Okay, let's come down and take a look at this 7/12, negative 7/12, which means my decimal is going to be negative 0 point something. Okay, so we're going to go ahead and do this division. 12 goes into 7 0 times. 12 goes into 70 5 times. 12 times 5 is 60. Subtract, I get 10. Bring down my 0. 12 goes into 100. 8 times is 96. Do my subtraction. Bring down the 4. 0. 12 goes into 43 times, and I get 36. Bring down a 4. Bring down a 0. 12 goes into 40. 3 times, I get 36. We are repeating our process here. So this 3 is going to continue because no matter how many times I subtract and determine how many times 12 goes into 40, I'm going to get the same answer every time. So my decimal here is negative 0.583, and just that 3 repeats. So this is a repeating decimal, still rational, but it is a repeating decimal. Okay, And you can have repeating decimals that are both positive or negative, and same with terminating, okay? They are all still rational numbers, okay? There are several more on this page that you can try on your own.